Okay, good evening. Welcome to
SuperMath122.
SuperMath122. So we've been studying some stuff relating to the Pythagorean theorem in geometry. And if we have a triangle where a squared plus b squared equals c squared, what can we say about the angle opposite c?
Well, the angle opposite c is a right angle.
Okay, how come?
Well, this is the Pythagorean theorem, and
Okay.
it works for right triangles.
All right. And if a squared plus b squared is greater than c squared, what can we say about the angle opposite c? So
C is obtuse.
okay, why would that be?
Well, because you're ending up... Because a squared plus b squared... Wait. It's greater than c squared?
Yeah, a squared plus b squared is greater than c squared.
So... I think that one was for an obtuse triangle. But... You still have the same sides, and you're extending. Like if you imagine you take the right triangle.
Okay, so let's look at like a 3, 4, 5. Okay, and now we make a triangle where 3 squared plus 4 squared is greater than this side. What's happening?
Well, you're actually pulling it. You're actually pulling it in.
Okay, what do you mean? Draw me an example with a 3 and a 4, and then where it's 3 squared plus 4 squared is greater than 5.
Like that. Actually, whoops. No. 3 squared plus 4 squared would be greater than whatever this is.
Okay, so you're squeezing the angle in. So what do you say about the angle opposite c there?
It's acute.
It's acute. Okay. And the last case would be a squared plus b squared is less than c squared.
Then it's obtuse.
Then it's obtuse.
Because you're pulling the angle apart.
Okay, you're pulling the angle apart. Now the book has some interesting examples, so it gives a bunch. So let's look at a 10, 11, 12 triangle. What can you tell me about the angle opposite 12, the side that length 12, a 10, 11, 12 triangle?
Well, it's going to be acute.
How come?
Because 10 squared plus 11 squared is greater than 12 squared.
How do you know that?
Because 12 squared is 144, 10 squared is 100, and 11 squared is 121.
Okay. Interesting. What about this? What about a 3, 3, 2 triangle, and the side opposite one of the threes, or sorry, the angle opposite one of the threes? What can we say about that?
Well, the angle opposite one of the threes is acute.
How come?
For the same reason. 3 squared plus 2 squared is bigger than 3 squared.
Okay. Now you give me 3 numbers.
How about a 10, 13, 17 triangle?
13, 17. Interesting. Okay, so let's look at the angle opposite, the 17. What can we say there?
Well, 13 squared is 169. 17 squared, I think it's 289.
289, okay.
And 10 squared is 100. So you get 269 when you add 10 squared and 13 squared.
Okay,
And this was 289.
right.
So this is an obtuse triangle.
That's an obtuse triangle. So one of the interesting things about what we've been studying is that you can now know, just by looking at the side lengths, whether a triangle is an acute triangle, a right triangle, or an obtuse triangle.
Yeah.
That's pretty incredible. The next section we're going to study will actually tell us how to figure out if it's a triangle at all.
Like if it satisfies the triangle inequality?
If it satisfies the triangle inequality. So for example, the old 1, 1, 100 triangle.
Would not satisfy it.
Okay, how do you know that's not a triangle?
Because 1 plus 1 does not add up to 100, so it looks something like that,
Yeah, that's the problem.
which isn't really a triangle.
Once you go 100, you've got to go 1 on either side of it and get back to where you started. It doesn't quite work.
Yeah.
But in this triangle up here, the 10, 13, 17, once you've gone 17, as long as you can go 13 and 10, you can get back to where you started. Okay, so that's cool. That's what we've been studying, and a little bit of why we've been studying it. The algebraic properties of the numbers tell us a little something about the geometry, which is fun. All right, good job, sweetie.